Okay, so question 2 on the sequences. So we said 9, this is a common difference, so the difference is 8, so this is 33, and then this is 41. Then the next one, these are square numbers, so 9, then 16 pi, and then 25 pi, and then the next one, total length of the circumferences, we are adding this and this and getting a new number, so this is 20 pi, and this is 30 pi. Then write down in terms of pi and n. Okay, in terms of n, the number of dots in diagram n. So diagram n, number of dots, it's this group here. So it means we are looking for n. What is the nth term of the number of dots? So we've seen that the first one, the difference is the same, it's 8. So this is actually 8n plus 1, because if we say 8n plus 1, then n is the position. So if we put a 1 here, this will be 8 plus 1, 9. If we put 2 here, this will be 16 plus 1, 17, and so on. Okay, then B says, find n when the number of dots in diagram is 1, 0. So we're going to say, find n when the number of dots. So number of dots is this one, which is 8n plus 1 is equal to 1097. So we have to solve for n. So it means if you do your calculations correctly, you're going to have 1096 divided by 8. So 137 is the answer here. Then write down in terms of n and pi the area of the largest circle. So, sorry, not very clear things here, but write down in terms of n and pi the area of the largest circle in diagram n. Okay, so area of largest circle is this second one. So now that they need is, what is the nth term here? So the nth term here is just a square number. So I mean 1 squared is 1 pi, 2 squared is 4 pi, 3 squared is 9 pi. So it's just n squared with a pi, with a pi like that. Okay, or if you want, you can say pi n squared. It's the same. So diagram 3n, it means 3n squared pi. Okay, which is also can be written as 9n squared pi, or pi 9 n squared. Find in terms of n and pi the total length of circumferences of the circles in diagram n. So the total number is this last line here. So we want the nth term for this line. So we said you have to get, for you to get this, you added 16 pi and 4 pi to get 20. 25 pi, and so whatever is here is treated as n pi. Okay, as n pi, because this is n, these are natural numbers, 1, 2, 3, 4, 5. So this is just the sequence of n. Okay, so this is just n. Alright, so if this is just n, so we are adding this to get this, but this is 25 pi, so we are adding the n here to get our answer. And the sequence here was n squared, so we have the sequence here which was n squared pi. Okay, then we are adding, so n squared pi, which is the sequence that is here, we are adding the first sequence, which is just n. Okay, sorry, n squared pi plus n, but we put a pi because we are adding, for example, when n is equal to 1. Okay, so for example, when n is 1, here we're going to have 1 squared pi plus 1 pi. So the answer will be 2 pi, exactly what we have here. To get 6 pi, n is 2. So if we put n is 2, n is 2, then you're going to have 2 squared pi plus 2 pi. Okay, 2 squared is 4, this is 6 pi. So this is why I'm just proving, but that is the answer. So that is the